An object has a charge of 3 coulombs and a mass of 2 kilograms. Determine the magnitude of the electric field that would create 12 Newton of force on the object. So the charge is 3 coulomb and mass is 2 kilogram and force is 12 Newton. Then the magnitude of the electric field is gonna be what we are finding. So we are going to apply this equation. So the magnitude of the electric field is gonna be 4 Newton per coulomb. The electric field of charged sphere has a magnitude of E and a distance r from the center of the sphere. How does the magnitude of the electric field at a point that's 1 over 2r from the center of the sphere compare? So we are going to apply this equation, and the equation of electric field is going to be K multiply the constant multiply Q over R square, and the R square is going to be 1 over 2R. We are going to apply 1 over 2R. So the electric field is going to be 4E. Two charged plates have a charge of 3 coulombs, are separated by a distance of 10 centimeters, and have a potential difference of 12 volts. Determine the magnitude of the electric field between the plates. Determine the capacitance of the charged plates. Determine the energy stored by the charged plates. So this is going to be the charged plates, and their distance D, and this is going to be 10 centimeters, and their charge Q. And we can find the answer of the first question by applying this equation. So 120 volt is going to be the answer of the first question. And we are going to apply this equation for solving the second question. So 0.25 farad is gonna be the answer. And for solving the third question, we are going to apply this equation. So this equation is gonna be equal to this, and So 18 joules is the value we are finding. And so the answer of the first question is going to be 120 volt, and you can find 0.5 farad as the answer of the second question. And the final answer of the third question is going to be 18 joules. Two parallel wires carry current in the same direction. One wire carries a 2 ampere current and the other carries a 1 ampere current. The force of magnetism acting on the 1 ampere wire is, so two parallel wires with current in the same direction will attract one another. According to Newton's third law, the same as the force acting on the 2 ampere wire and the wire attract. So the force of magnetism acting on the 1 ampere wire is gonna be attract. Bore radius is equal to the most probable distance between the proton and electron in a hydrogen atom in its ground state. The charge on an electron is equal to opposite to the charge on a proton, which is 1.60 times 10 power minus 19 coulomb. The Coulomb constant has an approximate value of 8.99 times 10 power 9 Newton meter square per Coulomb square. The electric force between an electron and a proton in a hydrogen atom has a value close to what value is the electrical potential energy of a hydrogen atom close to? So we are going to apply this equation. So we can find 1 times 10 power minus 7 Newton. And secondly, we are going to apply this equation also. So So we can find 7 times 10 power minus 18 Newton. So the answer of the first question, the electric force is gonna be 1.1 times 10 power minus 7 Newton, and the electric potential energy is gonna be 7 times 10 power minus 18 Newton. There's a 12-volt battery that delivers a 1.5 ampere current to an electric motor connected across its terminal. What's the power of the motor? The amount of electric energy delivered in 5 minutes is. So the voltage is going to be 12 volt and the current is going to be 1.5 ampere. So we are going to apply this equation. So 18 watts is going to be what we are finding. And for finding the amount of electric energy, we are going to apply this equation. So the amount of electric energy delivered in 5 minutes is 5,400 joules. Particle A, with charge Q, exerts a force F to the right on a particle B with a charge of minus 2Q. What's the magnitude and direction of the force exerted by particle B on particle A? So there is particle A with charge Q, and there is particle B with charge minus 2Q. So according to Coulomb's law, the forces exerted by each particle on the other are the same. Because the particles have opposite charges, an attractive force is established between them. Therefore, the magnitude of the force are the same, but the direction is opposite. So the force is gonna be to the left. Force to the left is gonna be the answer. Charge Q is established on electric field. At a distance of 40 centimeters away, the strength is 60 Newton per coulomb. What's the magnitude of the electric field strength at a distance of 80 centimeters away? So we are going to apply this equation. We can find the electric field strength by using this equation. The distance is doubled, then the electric field strength is going to be 1 over 4. So $16 Newton per coulomb times 1 over 4 is gonna be 15 Newton per coulomb. The magnitude of the electric field strength is 15 Newton per coulomb. Suppose Q1 is 12 times 10 power minus 6 coulomb and Q2 is 9 times 10 power minus 6 coulomb. Where on the x-axis must a negative charge Q be placed such that the resulting force on it is 0. So this is gonna be x-axis, and this is charge 1 and charge Q. So charge 1, this is the magnitude of the charge 1, and this is the magnitude of charge 2. Because the resulting force on it is 0, the force exerted on Q3 by Q1 must equal the force exerted on Q3 by Q2 for the forces to cancel. So we are going to apply this equation. And this means this and this is same. So the charge 3 is going to be placed on the 1.60 meter. A proton enters a magnetic field directed out of the page, traveling from left to right. The resulting path of the proton is a circle. What's the radius of the circle in terms of the mass of the particle, velocity, charge, and magnetic field? If the proton moves in a circle, the magnetic field must equal centripetal force. So rearrange to solve for R. You can find this equation, and this is gonna be the answer of this question.